Welcome everyone to this episode of Circuit Adventures. Today we are going to build a delayed off timer. It is one of the classic circuits you must know. You must have come across its implementation in a car dome light, where the light stays on a few seconds after all the doors are closed or the car is locked. But instead of throwing a circuit diagram on your face, I would like to start with simplest component available and together build an understanding of problem, understanding of working of each component, and then slowly build up a solution. Let's have a look at the available components. We have a resistor, a capacitor, an inductor, and a MOSFET. If you ask me to describe each component in a single line, I would say a resistor resists the flow of current, a capacitor stores some energy or charge, an inductor also stores some energy in the form of electromagnetic field, and a MOSFET turns on a large flow of current given a sufficient voltage at its gate terminal. Since we are about to deal with some sort of timing mechanism, it is evident that we need to have some sort of storage mechanism and a control mechanism, kind of like hourglass. For now, let's keep the resistor and MOSFET away and focus on a capacitor and an inductor. It is true that we can use an inductor for this problem, but electromagnetic fields tend to be a little more complicated, so I would go with a capacitor. A capacitor acts as a battery. We can charge it or discharge it really quickly. We actually have to reduce the speed in order to have some control over the system. This reduction of charging or discharging, in our case discharging, will give us the ability to create delays in the circuit. Let's start building a simple circuit where we charge a capacitor. Nothing more than a switch and a capacitor. As soon as I press the switch, the capacitor is charged within few milliseconds. And even after I release the switch, it stays charged because there is no discharge path. Let's add a discharge path, that is a resistor, to it. You can see it works. We have a circuit that charges quickly and stays charged for few seconds. Congratulations, we have created our basic timing mechanism. But can we decide how long it stays on? Fortunately, some really smart minds have already quantified this problem for us and is given by this equation. Now we can use any graphing calculator like Desmos to plot the discharge curve. This gives us a really precise idea of what voltages we have on the capacitor with respect to time, given a value of capacitor and a resistor. Or we can calculate the value of resistor given the time requirements and capacitance. As you can see here, it takes about 3.5 seconds for a capacitance of 470 microfarads to discharge to a level of 2 volts through a 8 kilo ohms resistance. Why 2 volts, you ask? Because we cannot add any load to the circuit like an LED or lamp. It would increase the discharge current through it and mess up our equation. We need something to isolate the control mechanism with the load. And what was that? That takes just the voltage on its terminal to switch a large amount of current flow? Yes, a MOSFET. And it turns on and stays on for voltage above 2 volts. Let's add this to our circuit: an LED to indicate the output, a resistor to protect the LED, and we have our simple delayed off timer. Let's test it with few different values of resistor and capacitor and compare them with our equation. I hope you have learned something new from this video and you will be able to create your own delayed timers. If yes, please leave a like on this video. And before you go, I have a question for you. a homework of a sort. I want you to think over it and write the best explanation you can in the comment section. I will read them all and pin the best explanation on the top. So here it goes. What will happen if I use a BJT instead of a MOSFET? It will turn off faster, it will turn off slower, no change or negligible change.